Hello everyone. So previously we had discussed on the algo longest common subsequence, right? So today we'll be discussing on the algo longest increasing subsequence, right? Let's get into the definition part here. What it states, the longest increasing subsequence, also known as LIS, is the longest subsequence in a given sequence where all the elements are strictly in the increasing order, right? So well, where all the elements are in strictly increasing order. The elements of the subsequence don't need to be this one, do not need to be contagious, but their order must be preserved. Just remember this one, order are in increasing order, and it might not be contagious as well, or it might not be continual, right? So let's move on with the explanation part. So let's move on with the explanation part here, man. So let's imagine if we have an array of numbers and we want to find the longest possible sequence that increases as we move forward, right? So here, example we have considered here as 10, 12, 9, 10, 22, 9, 33, 21, 50, 41, and 60. So possible increasing this one subsequences are one, see here, 10, 22 followed by this is the next number actually 33, next 50, as well as the 60. See here, you can clearly see here when I click, right? So this is also one of the possible sequences, 10, 22, 33, 41, as well as the 60, right? So this is also one of the possible increasing subsequences, right? Both have the length 5. So the this one longest increasing subsequences length is quite obviously 5. So this is one of the simple examples, right? So we can solve this in big of n square using dynamic programming. Yeah, so we'll be making use of DP to solve this particular problem. What we will do, let's see. So we'll implement the same exact thing in the form of code within the algo. Just try to listen to this. For each element, what we will do, we will check all the previous elements. If we consider this one, for each element, we'll consider all the previous elements. That's what we do. Right? If the current element is greater than the previous one, see, let's consider 22. 22 is greater than 10 here, right? Then we can extend the subsequence. Then we can extend the subsequence, right? Quite obviously, we will be considering this one 10 along with the 22. The same thing will be continuing. We will store the length of the LIS, or the longest increasing subsequence, ending at each element, and we will take the maximum one, and we'll take the maximum one, right? So the same thing, let's try to implement or articulate in the form of code, right? So first, so we'll be making use of the Python programming language, right? So let's go with here the function longest. So this is increasing, right? Increasing subsequence, longest increasing subsequence of array. So this is fine, man. So within this array, first step is let's get the length of the input array, man. So this one will be length of what do we call array. Yeah, now let's move on with the step two, meaning let's create the DP array that is initialized with one. Also, let's keep each element, meaning let's consider each element that is an longest increasing subsequence of length one by itself. So I can just write it in this way, DP equals 1 into n. Yeah, this is fine, I believe. So let me give here 1 into n. Yeah, the next step would be, let's go with the step 3 here, nothing but we have to build the DPRA. So this is one of the easy algo, man. Easy algo. So let's build the DPRA, man. Again, so two for loops, n square time complexity. So let's go with the two for loops, or I'll just go with here for I in range. Actually, what's the range from 1 to n, and also for j in range here, range, what's the range, 0 to I, 0 to I. For I in range 1 to n, nothing but for each element we are considering. For j in range 0 to I, nothing but we are checking for all the previous elements, right? As discussed on the explanation part. Now, if the current element can extend the subsequence, uh, then how can we articulate that one in the form of code? When, or let's make use of the if here, if condition, if array of I, if it is greater than array of j, right? Array of j, then only if the current element can extend the subsequence that we are checking, right? So then if it can, then we will be updating the longest increasing subsequences, a subsequence ending at the I. So this one will be writing in this way, dp of I equals max of, what do we call here, dp of I along with the dp of I, it will be dp of j plus 1, dp of j plus 1. So we are just updating the LIS ending at the I. So let's return the maximum LIS length, longest increasing subsequence length. Return nothing but here, return here max of TP, max of TP. This is fine. Yeah. Now let's go with a simple example input, man. Yeah. So this is it for the algo. Simple one. Yeah. See here, I have considered the simple example, man. So this is nothing but the example input, the same example input that we have considered here. The output we have to get, we already know here. Why we have to get the output also, we have to know. We know actually, sorry. Result, I have been just calling this one function here, longest increasing subsequence function, this function here. This is fine. Or we are just passing the array input that we have considered here, right? We have considered around 4, 5, 6, 7, 8 elements, right? So finally, we are making use of print for the interactive purpose, length of longest increasing subsequences along with the result that we need to get, right? Based on the algo that we have written. Now, if I try to run the code, we have to get the output basically. What is the output that we need to get here based on the algo? So length of the longest increasing subsequence is 5. So this is also 5. This is also 5. 10, 22, 33, 50, and 60 also we can consider. This one also we can consider. Both are of the length 5 actually. We have to get length of the longest increasing subsequences 5. Let's check the same. Let's check whether we get the correct output or not, right? So let me come here, copy this one. Let me give Control J, clear screen, and let me give Python followed by file name.py. So see here, the length of the longest increasing subsequence we are getting here as 5. So we are getting the desired output. Yeah, we are getting the desired output. So whatever the code that we have written or whatever the algo that we have written works absolutely correct here, right? Works absolutely correct, right? So this is it for the longest increasing subsequence algorithm. So before moving on with the next algo, so let's discuss the summary part one, or let me summarize whatever we have learned so far, right? So the first thing here would be just listen to this, or just try to remember this 3 or 4 points, man. This is very important. Yeah. Now the longest increasing subsequence, nothing but LIS, what it does, it finds the longest ordered subsequence where elements strictly increase, right? So that's what we had discussed. So dynamic programming, we have made use of the dynamic programming, right? So dynamic programming efficiently computes this by comparing each element with the this one. What do we call? Comparing each element with the previous element, right? Yeah, dynamic programming efficiently computes this by comparing each element with the previous one, right? So what is the time complexity and the space complexity? Time complexity of this algorithm is big of n square, as we had discussed. Here, 2 for loops, you can directly go with the this one, big of n square. And what is the space complexity here? The space complexity would lead to big of n. Yeah. So this is it for the this one algo actually. Yep. So now we are done with the longest increasing subsequence algorithm. Yeah. Next, we will be discussing on the topic matrix chain multiplication algo. Yeah. Next, we'll be discussing matrix chain multiplication algorithm. For now, this is it. Thanks for watching, guys.